Okay, so now so basically the model is downloaded. So just a note, like once you turn off the machine and turn it back on, everything will still be in its place. So you don't, the process that we just did where we had to install some software and download the model, you only have to do that once. And then once you have that computer, it'll be able to just continue to do style transfers indefinitely. So basically, the way to do this style transfer, we can look at the neural style guide, and it says the basic usage is th neural style.lua dash style image, then the path to a particular image, dash content image, then the path to a particular style image. So let's do that. Oops. So we'll do th neural style.lua, right, there it is, dash style image, and our style image is going to be Wally, and dash content image, and that's going to be image this, and then hit enter. So let's hope it works. Successfully loaded the model. Tells us what layers are in the model, and then it starts to do the process. And basically, it's like with Deep Dream and Neural Synth, it's an iterative process. So it goes in steps. At each step, it calculates a gradient, which is the difference in all the pixels that it needs to add to the original image, and then it adds it to the image. And then it recalculates the gradient and adds that to the image, and then recalculates the gradient. It does this continuously, and it does it for some number of iterations. And by default, it'll do it for 1,000 iterations. So it'll do 1,000 updates. You can change this number. You can make it do it longer. If you do it longer, then you should get a better image in some sense, although in practice, the gradient will continuously shrink to 0 eventually. Like if you do the first 500 iterations, you'll get a certain result, and then after that, the change will keep decaying. So there's a limit to how much you can really do and get results. And it'll also save the final output to a file called out.png. And also by default, it will actually save the in-progress images, because it does this update, adds to the pixels, and it continuously does that 1,000 times. So it actually, by default, saves us steps along the way at spaces of 100 iterations. So we can actually see how they look. So like here's the original image and the Wally image. And then this is the process after, let's just takes a little while to load. It's done now anyway, so we can actually look at, okay, so just as a reminder, here's the original image. It's taking its sweet time, coming up on screen. Here's Wally. So this is the style image. This is the content image. This is the image after 100 iterations. It's a little slow. There it is. So first of all, that's just after 100 iterations. It starts randomly, and then it begins to converge. And so after 100 iterations, it looks like that. After 200, so here's 100, 200, 300. Let's go all the way to the end. This is after 1,000 iterations. Oh, it's pretty sloppy. Okay, so a few things now. We can begin to iterate on this a little bit. So I mean, well, you kind of see the thing about this is, I kind of suspected this would happen. The Wally is like it's like too small. Like styles that work really well are styles that have like a lot of something very distinct about them, like repetitive features. Those tend to work very nicely. Let's think of another one. Let's download another image. Okay, someone else call out a style. What was that? Mondrian. So I've actually tried Mondrian, and that one doesn't work very well for a different reason. Because no, that's kind of great. That really works nicely, but it has like a square that's like one color. It might kind of work, but it might. Well, all right, let's just try it. I don't know. Like, who knows? Oh, sorry? Dali, but the thing, well, maybe, but that's more content than style, right? Like, okay, Mondrian. Let's try Mondrian. Which one should we do? This one? Or this one? Klimt works really nicely. The Kiss is a favorite. Oh, that's got a weird drop shadow. That's too small. This one. So, sorry? It's not actually Mondrian? There's a lot of knockoffs, right? I mean, it's like really easy to make a Mondrian, right? It's like, it's Escher. Ooh, I like that. Can we do Escher? All right, let's do Escher. Sorry. Which one?
The one with the hands, no? The two hands,
Okay, the stairs or the hands. I think maybe. Hang on, I'm just trying to. I think this might work kind of cool because of the repetitive features. So like the same shape here. Let me try this one because I don't actually. I'm trying to apply whatever knowledge I might have. I think this will work well. So copy image address. I'm gonna wget it. Oops, not wget. Okay, so let's do that again. And also, let's also, get out of this. So there's TH style image. So I'm gonna go over this to this and change it to be, well, let's rename this file Escher.jpg. So let's use Escher.jpg, and now we can actually also, because we've done this once, let's add another argument to it, so we can actually make it a little bit bigger. Image size, and then let's do 1024. This might run out of memory, I think. So by default it'll make it 512 pixels on the longest side. Now this is the thing is that it's memory limited. Basically, the amount of video memory, like graphics card memory you have, is a limiting factor for style transfer, because the bigger of an image you want to make, then the more activations it has to save at every layer, and at some point it runs out of memory. So I know that like 512 it'll work reliably, but 1024 it's probably, let's try this. It'll probably run out of memory in 1 second, and if it does, we'll try to do something smaller. And, or maybe it'll work actually. It has, I think, 8 gigabytes of memory. It actually looks like it's working. That's surprising. Okay, so maybe 1024, much more than 1024 won't work. There's so there's various ways of getting it to work a little bit better, to work with less memory. One thing is using the CUDNN backend. Now we don't have CUDNN in this installed, so I'd have to do that. But that will help the GPU memory. There's various ways, and it's actually written on the, if you go to the script, it'll tell you about how to get better memory. Also, if you have, I've been actually doing very high resolution ones recently, because there's some tricks you can do. So if you can't do it on Paperspace because Paperspace is limited to the amount of GPUs you can get. But you can get, for example, on Google Cloud Compute, you can get a machine that has 4 GPUs or 8 GPUs in one machine. And this actually lets you do multiple GPU. Yeah, multi-GPU scaling. So this shows you how to do that. If you have multi-GPUs, you can get more resolution. So I've been able to get like over 2,000 pixels, which is, but we're not going to be able to get that in the Paperspace, unfortunately. But 1024 is not so bad, actually. So let's see. So first of all, it takes longer. Now, why does it take longer? Because it's twice as big And actually that means it has 4 times as many pixels, right? Because it's twice as big in each dimension. So there's 4 times as many pixels, which means that this takes roughly 4 times the amount of time to generate. So it's going pretty slowly. We're already about 1/3 of the way through. We can look and see how it looks. So this is output 1. So wait, this is the original image. This is output 1. After 100 iterations, okay, not super appealing just yet. At least it's bigger though. Okay, or let's see how it looks after 400. So once it gets to 400, while this is doing it, while this is okay. Well, actually, before we look at 400, why don't we look at through some of the other parameters? So this is a bunch of the stuff that comes with this that you can make changes to get some different effects. So one thing you can do is there are 2 parameters called content weight and style weight. And the content weight and style weight are the relative importance you attach to content reconstruction and style reconstruction. So the ratio of these makes a difference. So if you have a high content to style weight ratio, then it will prioritize reconstructing the content a little bit more. So like on the left here, this is Brad Pitt in the style of Picasso's self-portrait. And if you have a high content to style weight ratio, then it'll reconstruct the content very well, but maybe not get a lot of the style features. Whereas on the other side, it'll not reconstruct the content very well, but get a high style correspondence. And actually, if you set the content weight to 0, then you're doing basically contentless style transfer, which is also known as texture synthesis. So that's actually the next thing we want to do a little bit of texture synthesis. So texture synthesis turns out to be like almost the exact same thing as style transfer. It's just contentless style transfer, and you can do it with the neural style image. So let's see how we're doing. We're at 600. Let's see what our progress is. So what was that? Sorry? I would spend a lot, which is why I have a computer back home that I use. You know, so like put high upfront cost. But then it's free to use. So that's not so bad, right? Have a little bit of an Escher type thing going. That's after 600 iterations. So it should be a little bit better after 1,000. It's kind of neat, right? Maybe let's get a third image. We'll do one more. Actually, all right. So the next one we'll just do texture synthesis. So let's think of something that we want to do texture synthesis with. What's a good texture? Let's get some creativity. How about what was that? Ocean. Yeah. Okay. Which one? Something with variety would be nice. How about this? That's good? Okay, so let's copy this. And first of all, is this done yet? Almost done. So 900 iterations. Let's see how it comes out. And the next one we'll do. Yeah. What was that? Flock of flamingos. Yeah, okay. Next one's going to be a flock of flamingos. So first of all, we'll do wget. So this is done. Let's wget this. And I'm just going to go ahead and start. So th neural style. We'll do the style image is now going to be another, it's going to be another, what is it? Another threat to the ocean. So this comes from some article. Another threat to the ocean, deoxygenation. That's that's great. And now we'll do content weight 0. So even though we're giving it the image as the content, that'll just copy the dimensions, but otherwise we won't get any of it inside. So let's do content weight 0. Oh, and let's open that. Is that right? Yeah, that's. So anyway, I'll just start this process and let's open this. So now it's starting to generate. And in the meantime, while this is loading, I'm going to find a flock of flamingos.
Just adjusting the constants to that function that's 1/2.
Yeah, exactly, the content weight. Which one do you think? How about this one? This one is a little small though. I think this is better. This is perfect. Yes. So I'm going to copy this image location. So here's our final output here. It's pretty cool, right? I think we got some nice results. So while this is generating, so this is at 100, we'll just do one more and then we'll switch gears to do something else. Okay, so I'm gonna git clone. Oh, what am I doing? It's not git, sorry. wget cd. And let's just change the name of that to Flamingo. Okay, so this is a little while of a process, so we'll let it kind of finish out. So you guys get the basic idea, right? Of style transfer. So here's what I want to do. While this is finishing, we'll do 2 more of these, but in the meantime, while we're waiting for it, I want to show you one more thing. I think we'll have time to do one more long thing, which is pix2pix. So we're going to learn how to do pix2pix. So that will be the focus of our last segment here. And by the time that we are done with pix2pix, I think it'll take us like a half hour or so. We should also be able to check up on our chart RNN. Let's see how that's doing. So that's actually about 2/3 of the way through. So that should be done in like a half hour, I think. So that gives us enough time to do pix2pix. So we'll do pix2pix. And we will also just do a Flamingo texture synthesis because I think that's going to come out nice as well. So in the meantime, let's do this. I'm going to exit out of these things. And I'm going to start a new, so let's get out of this. And I'm going to start a new thing here. And I want to show you how to use pix2pix. So pix2pix is a repository. There are several pix2pixes. The original one is in Torch, which you can find here. However, I've actually come to start using the TensorFlow version of it because I slightly prefer the API. They're almost exactly the same. So, but the TensorFlow one's like kind of convenient. And also the TensorFlow one's kind of nice because it also has code for setting up a server client type thing, if you wish to do that, if that's something that interests you. But otherwise, I'm going to just take pix2pix TensorFlow, which is here. And we're just going to follow the instructions, so I'm going to clone it first. Okay, so where are we? So I'm going to git clone pix2pix TensorFlow. So first of all, just as a reminder, what does pix2pix do? I've already shown you this a few times. It lets you train an image filter on any related category of images, right? So like any 2 categories of images that are parallel, basically. Pix2pix does have to be paired. CycleGAN does not. So that's something we might even have time possibly to do CycleGAN. Yeah. Now, actually, like if you go to ML4A, you also see that I've written a guide about this. So if you go to guides and then you find pix2pix right here, pix2pix tutorial, you can go into there, and I have a long article tutorial that explains how to use pix2pix TensorFlow and some examples of projects that you can do with it. But in the meantime, let's go. So that's something that might interest you later. I'm going to go back to the TensorFlow repository. And gonna, oh, we already cloned it, right? Yeah. Okay, so I'm gonna CD there. Now here's the fundamental limiting factor here of pix2pix TensorFlow, or pix2pix, is that you need a data set. The data set is to contain several hundred examples of paired images. Now that's pretty hard to just come up with one on the spot. It's not like style transfer. We can just go on the internet and download some images. We need a large data set that contains paired examples. Now fortunately, the pix2pix ones, it comes with several sample data sets. So we can just do the samples. So why don't we do that? We'll just use the samples. We'll do a tutorial on training one of these on one of the sample data sets, and then we can talk about potential ways of doing generating your own data sets, which is something that you can do in your own time later. So let's see how this is doing first of all. Oh, it's almost done. So actually, since this is almost done, because I really want to see this Flamingo thing. So first of all, let's just see how this plays out. We got 50 iterations to go. Be done in 1 second. And in the meantime, yeah, there we go. So let's look at, this is our texture synthesis of ocean. Ooh. That's kind of neat. Sorry? That's what? Well, we made the content weight 0, so it doesn't attempt to reconstruct the content at all. So basically, it just ends up being a texture synthesis. It's kind of neat, right? Let's do the Flamingo thing. So go to this neural style, and I'm going to switch to Flamingo, and we'll let that go for a little while. Let's see if we can make it even bigger. So Flamingo. And we'll make the size, let's see if it'll even get up to 1280. I think it's going to run out of memory, that's my guess. Maybe we'll be able to get up to like 1100. And yep, out of memory. So that's what happens. Okay, fine. Let's try 1100. That'll be at least a little bit bigger. So, and I think it's working. Okay, good. Okay, so now let's look at pix2pix TensorFlow. So they have a few repositories here, and we can actually check them out. So here's the instructions, right? It goes, okay, download one of the data sets. You can download facades. I'm actually going to look through download data sets and see what's in there. Here's download data set, and there's, where are they? What are the local URL open data sets? Project data sets, data set is, oh, I see, okay. Well, which data sets are available? So it has, okay, it has facades, it has cityscapes. Let's pick one of these. Shall we do the shoes? Or handbags? Shoes or handbags? Okay, so raise your hand of shoes. Raise your hand of handbags. It's a dead tie. How do we, all right, let's flip a coin. Okay, let's do this. Okay, import random. Okay, if r is less than, it's a number between 0 and 1. If r is less than 0.5, we'll do shoes. And if it's more than 0.5, we do handbags. So shoes less than, handbags more. Ready? Handbags. Best 2 out of 3? No, I'm just kidding. All right, so handbags. So edges to handbags. We'll download this. Okay, so we'll go to our terminal. Let's download the data set. So let's take just a second. We'll go to pix2pix TensorFlow. Takes a little while, I guess. In the meantime, I'll tell you kind of how the data set is set up. So first of all, this is basically like, as soon as you see the data set, you'll know how you need to prepare your own. The data set comes as images, which are 512 by 256 pixels, and the way it takes the images and groups them into their two pairs, into the two objects for each pair. So basically, like, you'll have one image of the edges on one side and the image of the corresponding shoe on the other side. And they're square images, so they're both 256 by 256, so next to each other it's 512 by 256. So basically, you need to come up with a data set that's structured just like this, and you can swap it in, and it'll work exactly the same way. So if you can think of a data set that you can make. So one nice thing is the whole edges thing. Edges to anything, you can make a data set of that out of anything. You just need a collection of, you know, whatever kind of a thing that you want to generate. Handbags, shoes, planets, you know, people, whatever. And then you can generate a data set by extracting the edges from each of those. So basically you would like use some sort of a software that can create edge maps from photographs. Like Photoshop can do that. You can program it using OpenCV to do like canny edge detection, and that can generate the other half of that data. Anyway, this download is taking quite a while. That's sort of annoying. Let's see if it's 8 gigs. Holy moly! Okay. Sorry. Are you suggesting we wait? Wait. Oh wow! I didn't realize it was so big. Oh, because facades is tiny. Well, it might be going pretty fast. Sorry? Oh, yeah, maybe that's a little bit too, because it's gigantic, I guess. You know, it actually might not show. You could do it, yeah, like, okay, maybe. Oh, where does it download it to, actually? Yeah, it's hard to tell where how far it is into it, actually. How about this? Let me do this. wget. Let's see how fast it goes. So the edges to shoes. So if we look at this download data set, I think it's just doing a. I didn't realize it was so big. So let me see. Hang on a second. So it basically does this. Oh, and it puts it somewhere. Yeah, it puts it in some temporary directory. So we'd have to find where the hell it is. Temp file. Sorry? Dash prep. Oh, in the. Yeah. Well, let me just do a like a tar GZ. So we'll do edges to shoes. And we'll just do a wget. We'll see how fast that's going. So that's going 10 megabytes per second. So this will take 3 minutes. So that will take 12 minutes. So okay, let's let it go, I guess. And we should eventually get our edges to handbags. But maybe we should stop it because 8 gigabytes might be more than we have space for. All right, since this is taking, I'm gonna cut this off. I'm sorry for the handbag people, but obviously that's too long. 12 minutes. So we'll let this download. This will take 3 minutes. In the meantime, let me show you what I think I have an example from the facades. Yeah. Hang on a second. So, for example, if we had the facades data set, it would come like this, where you have images like this. Basically, each of these are 512 by 256, and it has one type of image on the left side and the other type of image on the right side. And so like the script actually divides them internally, and so we don't have to deal with that. So if you structure your data set like this, then you can train a model. So let's look at the documentation for training. So for training, so basically we'll go back to documentation. And then the basic training script does this. It says, okay, run pix2pix.py, mode train, and then there's a few arguments that we have to get, right? So first of all, the input dir is the directory of the images that you want to train it on. So typically you need, like, let's say at least 500. Ideally more like 1,000 or something like that. And then the output directory is where are you going to save the model to? Like, you're going to create a new folder and you can give it a name. So, you know, if you were training facades, you would call it facades train. And then which direction is, are you training it to go from the left image to the right image or from the right image to the left image? So you can do it either way. So for example, if we wanted to do if we want to generate facades from label maps, we would go right to left, right? Right to left. Right to left is B to A, left to right is A to B. So and then lastly, the number of epochs. Now epochs is, again, how many times should we cycle through the whole data set. 200 is a good number. 500 is a better number. We will not have so much time, so I'm going to set the epochs to be something really low so that we have enough time to actually look at the result of it. So I'll set it to be something like 25 or 30, which means that we won't get the most compelling results, but at least we'll have something to look at. Okay, so basically this should be done. Yes. So tar, what is it, ZF, something like that. Edges to shoes. What is it? XVFZ, is that right? XVFZ. Okay. So we look at this training folder. I shouldn't have opened that folder because Jupyter is really bad at like displaying in the browser the folder that has many items in it. So I actually want to abort that. Okay, good. Okay, so we have this folder of edges to shoes. I'd like to see at least one, maybe, if we can kind of oh yeah. Yeah, let's look at one of these. So 512 by 2. Oh, they're actually, is it? Yeah, it's actually, I think, possibly bigger. No, it's 512 by 256. So which way do we want to train? Do we want to be able to go from a sketch to a shoe? Yes. All right. So let's train A to B, right? Okay. So we'll go to this and we say Python. Let's go a little slow there. pix2pix -- mode train -- input dir edges to shoes / train. We'll use the training folder. This is getting slow. How's the internet in here? Hello? That's not good. Oh, it's this weird, yeah, it's this thing that Jupyter Lab is in beta. So if you don't click into folders that have many items, that makes everything screw up. Okay. Edges to shoes, train -- which direction, A to B, and then what was it, num epochs, right? Max epochs, and the output there. So max epochs. Let's do 30, and then output there is going to be our shoe. Okay, so this. Oh, first of all, yeah, our neural style is done. So first of all, our neural style is done, so we could look at that. We forgot all about the flamingos. So let's look at the flamingos. So first of all, before we do that, let's just see how this is going. So this begins to train, and this will take a little while. Let's just see how long it should take. So there are 5,000 minutes left. That's a joke. The estimate's wrong. So basically, it's taking 6.9 seconds per step, and there are, how many steps are there going to be? Oh, this might actually take a while. So we could make this take less. Let's see how long one epoch takes, and then we can always interrupt it actually. So that's the thing. So while it's training, if you ever get impatient, you can just stop it, and it'll have a model saved. So let's just let it go. It'll probably get, through a few epochs, because the data set's much bigger than facades, which is what I usually use. So we'll let it go, and then at some point when we're ready to see results, we'll cut off the training and we'll evaluate it. I think it has to at least do a few epochs to get some results. So this might take a little while, but let's evaluate. So in the meantime, while that's training, let's go back to our neural style and see how the flamingo texture came out. Ready for some flamingo texture? 1100 pixels. There's our flamingo. So that's the original. And that's what we have. It's kind of neat, right? Anyway, that's neural style. While we're training pix2pix, does anyone have any questions about neural style? Yeah? Yep. Yep. Right. Right. So here's the story. So the question was about the app Prisma. So maybe some of you have this app that does style transfer on the phone. And the question was, why does it run so fast? Because basically you take a picture and then it generates some style transfer of you, and it takes a few seconds. So the reason is that it's using a slightly different technique, which was developed about a year later than the one that we're using now. And the trade-off is that it doesn't actually look quite as good or generate as much of a high resolution, but it goes fast. So basically, the technique that we use for style transfer is this sort of optimization-based technique where we download some pre-trained like neural network, some pre-trained data set, and we use it to evaluate this loss formula. So this loss function. We forward both the output and the style image and the content image through that network, and then measure its activations, measure the loss function, and then do gradient descent on the pixels, just as we did for Deep Dream. So this process is really slow because for every iteration, it has to forward the 3 images through the neural network. Or, well, it just has to forward the output because the style and the content don't change, so you could do that once. But basically, it takes 1,000 forward passes through a neural network. So that takes a really long time because neural network is, each iteration will take, a quarter second or something like that, right? So later, they said, okay, is there any way that we could do this fast? One way of doing it fast would be to train another neural network to take as its input an image, the initial image, and then go very quickly and generate the output image at the other side of the network. So basically training a second neural network on many, many instances of a particular image style, or for a given image to generate like a neural network that will restyle in that style. So this is a sort of fast style transfer, the so-called forward pass trick. So Prisma uses that, and there are other repositories which use that. There's one you can find called Fast Style Transfer. If you look up Fast Style Transfer, you'll see this. And I have a fork of this, which lets you do it on the webcam. So this is by this guy, Logan Engstrom, I think. And it does Fast Style Transfer. You see it gets pretty decent results. But it doesn't, but it's kind of constrained, I find. Like, it doesn't work very well for every style. It does work very fast, though. It works so fast that you can do it on webcam. So I have an app, or I have a fork of this that lets you do it on the webcam. Yeah. So it works pretty fast. But it doesn't quite look just as nice to my eye or generate high resolution. So if you want to get the fast version, you can use that. Any other questions about neural style? Incidentally, pix2pix can do style transfer too. That's basically what pix2pix is. So it is also a fast version of it. But the optimization-based technique, I find still kind of, if you don't have this constraint that you need it fast, I find that it generates bigger or nicer images and also generates bigger ones. Any other questions? Okay. So we're still through one epoch, so this thing is going to take a while. Well, okay, so here's what we'll do. Let's check out char and TensorFlow. Let's see how that's doing. That is almost done. Look at that, perfect timing. So let's do a sample. Okay, so I just want to warn you, it's not going to be amazing, because really, if you really want to do a good job at char and TensorFlow, you would train it overnight. You would train it for like 24 hours, 48 hours, and maybe on a bigger data set. However, it'll work decently. It'll at least give us the idea. I don't even remember what we trained on to by now. It's Ulysses, right? So who has read Ulysses? I have not. So I don't actually know what it should sound like. Okay, well, let's have a look. So first of all, we can go back to the documentation for char, RNN, TensorFlow. Multi-layer recurrent neural networks, LSTM. So this basically tells us how to sample, and that's basically using Python sample dot, where is it, sample.py. Python sample.py, and it also needs, so basically we can go to this and say, okay, Python sample.py help, because we need to set the actual directory we're saving from, or loading from. That's the save there. So if we do Python sample.py save dir and find a directory that has, let's see here, it's in save. It's in the same one, so we can just use save. So save dir equals save. And then also n is the number of characters to sample. So default it does 500. Let's do actually 5,000. And there's one other thing I'm going to do. This is just, you don't have to do this, this is an optional thing. Sample.py, if you look at it, when it outputs the thing, it encodes it in UTF-8. So then what it ends up doing is every new line character gets this Unicode, like it's like /RC or whatever. It's basically like the encoding for just characters it doesn't understand. I'm just going to remove this because it'll be easier for us to read it. So I'm just going to save that and then go here and then generate. And loads the model. And it's just going to generate, yeah, here we go. His fell for the heteros of God. Fassery took 4 high physic, a top park, and in the car only put up. All then he walk off her attacked his bib on corks. Ireland see ourselves. There is window in account from superior. So it makes up a lot of words because it's a character by character model. So it might sometimes make up words. Jairus 14, a bard. Welcome, tone, in the sea, deem. Does James Joyce have a lot of things where he has like a short phrase, like period, short phrase, period, short phrase, period? Is that like a thing that he does? Yeah, this looks, so that's kind of cool. It found that sort of, that strategy very quickly, relatively quickly. Only took an hour and a half. It just like forgot, you know. It's like, yeah. Dash dash. No, oh, you mean the temperature maybe?
It samples either spaces or not spaces, or when.
What was that? Oh,
That's
0 to use max at each.
One is the default.
Uh-huh.
And it generates different things.
1 to sample at each time step, 2 to space. Oh, okay. All right, let's try it. All right, let's see how that. I'm not actually sure what that'll do. While it's doing, I'm just gonna check on this. To do with the last and the death and was present residence and his soul to be which was a particular quarter, Ben Alexander Madam assested himself with the problem Haynes and S. Beller, Millicent McDowell and the devil in private con me respected on the strand hand to Mr. Power of others and property by North Howard explained on the Kildare. That's amazing, right? Dublin Fitzgerald, that sounds like pretty Irish. And then what does 1 do? Marion towards the house stops, then uncover head with his neck named disc. Ever noddling cattle paper for things like that green stick. That's great. So you get the idea with char and TensorFlow. You can train a chatbot. You can. So I've trained it on. So I've been keeping a journal for the last 6 years. So I have a little journal. I record everything I do. It's like many megabytes now, just a little bit every day. And I once trained it on it, so it started like making up memories, basically. You know, just like it's like it written like it. So if you can get a large body of your own writing, you can train it to generate writing like yourself. So one thing you can do is you can export all of your email from Gmail, if you have Gmail, or you know most online services let you export your email, and you've probably written a lot of email by now, right? So that's good. That's a lot of training. So I've looked at like, let's see if I can find it, like char RNN. Email. I can't find. I've probably saved it somewhere. Text learning, yeah. Data. Oh yeah. This is one trained on my email. So it's writing emails like me. It's like I see it, it's like ending my emails. Interface, how are you short thing as in the programmer or in the confirming cross then? I haven't had me when you know what she's every. Carol has a few hours. I even know who this is, like because you know like it'll learn names, right? And then best Gene. I end all of my emails basically this way. So like it'll learn, you know, habits of yours. Brooklyn, should I am happy? You know, it feels vaguely personal because I'm sharing with you like something that is fundamentally coming from my sent emails, but it doesn't make any sense at all. So you can't really. I had visualization, not for such the service. It's great, right? So I have no idea. It makes up words. Oh, this is my very first, or like my first, not my first website, but my first, like the precursor to my website now. Doesn't exist anymore. So, yeah. So I mean, it doesn't understand language. It'll work on any text that you give it. Oh yeah. If you give it like, you're not the first person to ask me that. So like, if your emails are like half of them are in one language and half of them are another, it'll basically just like code switch between the two of them. So you'll see like it'll have one word or like a phrase in one language, and then it'll go to another language. If your emails are usually in one language, then it should have long blocks of one language and then switch into the other language. Like, yeah. If anyone okay, so I assume that a lot of people write in Chinese here, so it might like one thing that you might have to look into, because you could do this with Chinese also, or any language. The only thing is that you might have a weird hiccup where if it's not like ASCII, it's not ASCII. If it doesn't have like an ASCII encoding or UTF encoding, it'll get messed up. It'll complain. It needs to be able to tokenize all of the characters, so it doesn't matter what the characters are technically, because to the machine it's all just numbers. But you might have to look into. I think it should probably work. We could try actually. Like we could download. So let's do that actually. Let's think. Where can I find this some Chinese like? How do I find? We could. Shall we try this? Where can I find like a big text file in Chinese? Which one? But where can I get it in Chinese, right? This might be like, it might be translated, right? No, see, it's translated, right? All right, well, yeah, it's going to be hard because I'll have to write it down. Anyway, all right. We don't have time for this. I was just musing. Like, okay, you might want to try to see if it works. It might actually just work, but I think it'll have trouble rendering it on the terminal. So you'll need to be able to transcode it first into some something neutral, like the Unicode character, like the Unicode code, and then whatever else later can render Unicode into Chinese, you could do that. Oh, so that might be a problem also, yeah. Okay, so first of all, like, did we want to do anything else with Charter and TensorFlow? Oh yeah, so like just the ideas, like you can train something on your own email. Be careful, because like when you export from Gmail, it'll give you all the attachments too, and you have to figure out a way to parse that out. They don't make it very easy. Yeah.
Model reviews, like those experiments you mentioned with text captioning, image, or vice versa.
Text cap.
So you know text describing
Oh, those are usually word level. Yeah.
word level, but they're also RNN.
They are RNNs, but they don't operate on the character level. So here's the thing that I didn't mention exactly. Like, okay, so this generates text, but anyone serious about doing text generation, so people writing chatbots or question answering services, typically do not use character level models, because think about how much information is in, at least in English and I guess like in Chinese it's different, but in English, like it would be kind of silly to operate on the character level, because there's a lot of information inside of a word. So it'd be better to represent words and then do a language model that includes words. And the way that's typically done is that every word is first assigned a vector, like a vector in some n-dimensional space. So like if you ever heard of word2vec or word vectors, we didn't talk about them in this workshop, but you could do word vectorization, and that's very typical for natural language processing. So every word is a word vector, and then it does the language model on the word vector level, and yeah, it'll do an RNN, no STM on them.
I'm trying to get the question out, like time, like the image doesn't have time, and the text does.
Yeah. So something that's generating text is, generally speaking, is usually a RNN. Yeah. Now there are various approaches to actually, like, you can do text generation with even convolutional networks that don't have time, where you kind of do it as like a where there is some sort of cardinality associated with the ordering of the pixels. They're not pixels, but they're data. But basically, you can interpret order.
Fixed size, like you're doing like a sentence or
Yeah.
text character.
So for example, like, okay, WaveNet, right? WaveNet, I mentioned WaveNet maybe at some point in one of these lectures. That's a generative model for audio, and it generates samples of audio, which are also ordered. And it actually doesn't use recurrent neural networks, it uses convolutional networks. And the architecture is able to produce, it has some mechanism for producing ordered samples. And there is a repository that tries to use it for text as well, like WaveNet, text WaveNet or something. Or there's also Pixel CNN for text. There's various approaches, but yeah. So, long tail of information. So any other questions on Charter and TensorFlow? Okay. So let's get back to pix2pix. We'll go to this. Okay, so this is still training, but I just realized, okay, we want to do some sort of an experiment, right? So we're training it, right? But we don't have anything to test it on, right? Now we can test it on the test samples, but it'd be much cooler if we could draw a shoe, right? So like, what if we wrote a processing script really quickly that would let us draw a shoe? It's a shoe, right? Yeah, it's a. So I'm gonna, while it's training, let's do this. I'm going to make a program that will let me draw with the mouse. It'll be really, really simple. And we could do like, okay, void setup, size. Let's make it this big so we can kind of see it a little better. And then as long as the mouse is down, so void mouse pressed, hold equals true, and void mouse released hold equals false. And we have a boolean called hold. And we say if hold, draw a line between mouse X and mouse Y, and previous mouse X, prev mouse X, p mouse X, like that. P mouse X, yeah, p mouse Y, and we'll do like, okay, so stroke black, stroke weight 2, and we'll do the background white. So let's see if that works. Yeah, not bad. Okay, so let's draw a shoe, and then I'll also say, okay, when I hit key press, we'll take a picture of it. So first of all, let's save it somewhere. Draw a shape. If key equals this, we'll save, who knows this? Save screen, save frame. Just like that, right? Okay, so like if I do this, blah, 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 now hit this key, and then I'll go to draw a shape. Oh, it saves a TIFF. So let's actually, right. Frame.jpg. Frame.jpg. Okay, right, cool. Now I think we want to make this a little bit bigger. Stroke weight 4, because it'll match the shoes. So let's first of all, let's stop the training. And let's see how it's doing. So we can test it actually by using the test script. So if we look at TensorFlow, where is it? Pix2pix TensorFlow. There's a testing script which will let you input a directory. And it goes, okay, so mode test. Input dir is another set of images that you want to generate from, right? And then checkpoint is the directory of the model that you are saving. So we're saving a model currently. There's a directory, so we'll have to reference it in checkpoint. And then output dir, in this case, is the folder that you want to generate the images in. And it'll actually conveniently, it makes like an HTML page that you can browse them. So now, the nice thing about the data set is that it comes with 3 folders of samples. It comes with a training folder, and then 2 folders called val and test. Don't worry about val. For test, it's a set of images which were not given to the training script. So we want to use one of those images, and they're exactly the same as the ones in the training folder. They're 512 by 256, and they have the sketch and the actual image. And the reason why we use it is because we're scientists, right? So we want to see what the actual output looks like. Like we want to predict an output, and then we want to compare it to the actual output. So we use some sort of a testing data set to evaluate visually how much they correspond. So that's what we can do with the testing script. So let's actually, oh, that's the Docker. So basically, yeah, let's do that. So here's what I'm going to do. I'm going to interrupt this. Our model saves every 5,000 steps or epochs. So we're basically, it just saved, and we're at 15,000. So I'm going to interrupt this. So that's done. I think we can just make sure that nothing's running. Yeah. So now I'm going to run the testing script, and we're going to say Python pix2pix.py --mode test --input dir, and that's going to be edges to shoes and then /test. That contains a data set of a folder of images. Is it test? Oh, so, val. It just has a val. Okay, so val, not test. And then output dir is going to be, let's call it test. And our checkpoint is going to be shoe. That's this, that contains the checkpoint. The checkpoint is another way of saying model. So checkpoint shoe, and then that's it. I think that should work. So then we run this, and then generation will be really fast. So it'll load the model, and then it will take all of the images inside of val, and then run them all. And there's quite a lot of them. We can look at and then it generates this index page. We can download this whole thing, although I feel like we don't want to because that might take too long. So we can just look at a few of the samples. So basically test, here's the test. It makes conveniently like an HTML page that you can view it on, but we don't have a browser inside of the browser, right? So instead I'm just gonna look at the images and we'll just look at a few samples. So click into images and you go, okay, well let's look at, here's the input. So it receives this input. And here's the actual target. So it's that. So this is the input and this is the target. And then this is what's generated by the model. Not bad, right? Let's look at a few more. Input 120, sandal. Here's, and that's, so this is the input, that's the target, and here's the output. Okay. Well, so first of all, they all end up looking kind of similar. And the thing is that like we didn't train it for that long. So again, like pix2pix, just like Char and TensorFlow, you want to let it bake for a little bit longer. We only trained it for not even one full epoch. So for a data set of this size, you would probably want to train it for longer. I think they show their results. I think Philip. Okay, so pix2pix, they actually have a data page where they show some of their results. So there's an interactive demo, and then there's also sketches to shoes. So if we look, these are their. Oh, right. So here they actually just made them up. So that's what we're about to do. So these are the actual generated outputs. Some of them are pretty wild, right? So if you train for a while, you'll get more variety. But we didn't train for that long. Okay, so let's actually generate a few shoes. Yeah? So then we'll just send them we'll make them in processing, and then we'll send them, and we'll generate a few of them, right? Instead of just using the testing images, let's actually make a new folder. And so like I'll make a new folder here, and it'll be like drawings. And let's just make a few in processing. Now the thing is, we have to give it a data set that's formatted exactly the same. 512 by 256, where there is a shoe on the was it on the left side or the right side? It was on the left side. And the right side, there has to be the actual shoe. Now we don't have the actual shoe, right? We're just drawing it. So what we can do instead is just make a decoy. We'll just have a blank image. All we have to do is make this big instead. So it'll be 512 by 256, and we'll draw it on the left side. So, and let's do something like this. Okay, so let's draw a shoe. I'm going to do my best to draw a shoe. It's hard to draw in such a small amount of space. So, okay, so I'm going to make should I make a sandal or a, okay, we'll just do, does anyone else want to draw? Okay, so I'm going to save that. So now we have this image. It's 256 by 512. It's exactly what we need. And it is, yeah, it's a shoe. Well, so let's, and there's nothing on the right side because we don't need a ground truth. We'll just get nothing. So let's rename this frame 1. Let's do like 3 of them. Now I'll do something like heels. What else? What other features should I put on this? Let's put some like, yeah, something wild, yeah? That's not bad, right? I should be a designer. Okay, so that's good. Now I'll save this. Let's rename it. Frame 2, and then one more. Let's do one more. Give me an idea, like a boot, a big boot. Yeah, there we go. And maybe like some strings. Okay. So we got 3 images. Oops. There they are. Beautiful. So now I'm going to throw them into here, into this. I made a drawings directory. So I'll just put them in there. There they are. So now I'll go back to this. And we'll say, okay, Python pix2pix mode test input directory is now going to be this drawings directory. And then the output directory, we'll call it test2. Test2, okay, so now I go to test2. And let's look at our images. So here's the input. Of course, the target is blank, so there's nothing there. So this is our output. Whoa, weird. Got some artifacts there. Let's try the other one. Frame 2 input, and then the output. Stylish, yeah? And then this one. So there you have it. So, okay, now obviously this is a very dinky example, but here's the point. You can, anything that you can learn a model for anything, right? Like you can, first of all, you can do the sketch to anything, right? Anything that you can extract edges from, you can download images of your favorite object. Someone did this for Pokemon, for example. Pokemon. Downloaded a whole bunch of Pokemon, and then ran them through like the Photoshop canny edge detection filter to get all of the edge maps, and then trained it to go edge map to photo, and then drew his own Pokemon, right? So anything that you can do edge detection on, you can generate with the edges to whatever flow, or you can come up with ideas like of things that you can get a natural data set from. So face detection is a good one. Pose detection is another good one. Of course, maps and satellite images, black and white images and color images, you know, day and night photos, things like that. Like whatever you can get a data set for, then you can try this for. Now the one thing, we didn't have enough time to get to this, but you can also look up CycleGAN, and there's a few implementations of CycleGAN. There's one implementation that actually has both pix2pix and CycleGAN in one. And it works incredibly similarly. Like if you look through the instructions, it says, okay, prepare a data set, put it into this folder, and then run the following command to train it. It says here somewhere. This is how you would run it. Right, and then there's generation script. And the difference between CycleGAN and pix2pix, CycleGAN does basically the same thing as pix2pix, except your data set does not need to be paired examples. They can actually be, in other words, like you do still have 2 different kinds of things, but they don't have to be ordered. So you just have, 400 images of horses, 600 images of zebras, and you put them into 2 different directories together, and it will learn the relationship between the horses and zebras. So this can do good style transfer. This is a way of doing style transfer, right? So here it learns a style transfer. Input photograph to Monet, Van Gogh, Cézanne. Also, it does apples to oranges, zebras to horses.
So how does it compare on the same tasks as pix2pix?
I don't know actually. It's a good question. I haven't done a comparison. You'd think so. I'm not actually sure. You'd be surprised. It's actually pretty effective. Although I don't know if what the. You'd think it would be worse because if you do have the exact, it seems like you're giving up information. So yeah, I would think so. I would suppose it's worse. But of course, in a lot of cases, you can't get parallel data sets. It's really difficult. So horses and zebras are a good example. It's like try getting images of horses and zebras in the exact same position. It does very good textural transfer, but it won't do so well if you try to do like cats to dogs, because like they have different shapes, and so it's a little bit more tricky. But texture transfer is quite good. Season transfer, right? Photo enhancement. That's pretty cool. So it learns a depth of image filter. Isn't that cool? That's really cool. So depth of image filter. So, yeah, and I can imagine that like your camera of the future is probably going to use something like that for depth of field. Once it's better than the lens, or at least it's more effective, So anyhow, that's pix2pix and tensor and Cyclogen. So we had time to basically get to Charn and TensorFlow, generating text bots, neural style transfer, and generating style transfers and texture synthesis, and also pix2pix. So those are some of the more easy things to do. Some of the more hard things to do is generating a full generative model like a DC GAN, right? So if you wanted to generate a GAN that's able to hallucinate objects of things, different kinds of objects. So you give it a bunch of faces and it makes new faces, or you give it a bunch of images of houses and it makes new houses. That is a lot harder and more limited. First of all, you can only do it at very low resolution, unless you really know what you're doing, and it requires lots of images, like thousands, if not tens of thousands. Even better is hundreds of thousands, and a lot of patience. But those are also things you can look up. If you search DC GAN, DCGAN, you'll find a few implementations of that. There's better ones out there that might be more complicated, but possibly more effective. So this is kind of the bleeding edge of the research. But there's different architectures that work pretty well. So those are things that you can, if you're very adventurous, you could try those things. I've had some fun with them. They're always getting better. You could even try running the thing that NVIDIA did to do this, where they get HD. But this I haven't tried, and this is probably very complicated because it requires a lot of video memory. So it requires very specialized hardware. It requires a lot of images, and probably some training, like babysitting the training process. So for that, you're on your own. I haven't tried. Okay, so that's kind of all I have prepared and all the time for. We have some time left, but we can kind of break things out. Like if you guys have some questions, some final questions for these 5 days, questions about anything that we've looked at, now would be a good time to begin listening up. Yes?
Both the neural style and the pix2pix require code, and it can only run Mac or Linux, so it doesn't run.
It requires what? Sorry?
Only Mac or Windows can run it, so it doesn't run with Windows.
You mean sure, it will run Windows.
But the Torch,
Yes, you might be correct. Like Torch might have limited Windows support. However, I believe PyTorch runs fine on Windows. So all of these things that I've shown you, I've just shown you one implementation, but there are TensorFlow implementations of all of these, and that'll run on Windows just fine. So like if you want to use pix2pix TensorFlow, that's in TensorFlow. There's TensorFlow-based neural style transfer also. So just search for that, and it works exactly the same way. So yeah, you can do all this stuff in Windows. Most of the development happens in Linux, so like sometimes Windows like is a little late to the game to get things, but generally speaking, you can do all this stuff in Windows fine. Yeah. Oh, another thing you can do if you're on Windows, you can use something called Docker. Docker lets you have a virtual Linux box on your computer, and you can actually just download like Docker models that already have everything set up. So I don't know how, what the Windows support there is, but basically anything that you can run in Docker, you can run in Windows. Windows Professional. For some reason, Docker doesn't work on the Home Edition, I think. I might be wrong about that, but that's the last I've heard. Yeah? More photos with smaller resolution is generally, is probably preferred these days, yeah. Because it downsamples everything anyway. Any other questions? This is it, so was there a question back there? Yeah? Oh, how do you close down paperspace? Good idea. So you would go to the console. Was anyone actually following along with the paperspace? No? Okay. So you can basically kill them like through the console. So like I'll go to new machine, and then basically like, so first of all, if you shut down, it'll turn off the computer and it'll stop billing you per hour, but it will continue to persist on your account. You could it's like having a computer, right? So you can open it again later, which is kind of nice because if you install some software, it'll be waiting for you there, and it costs only like $6 per month to just keep it. If you want to get rid of the machine, you have to deactivate it. So deactivate. So you can shut down and deactivate, or I can just go straight to deactivate. So I'm going to deactivate, so that'll kill the machine, and then also deactivate. It's like, this cannot be undone, so goodbye. And then it'll take like a few seconds, and then it'll get rid of it. And then one thing, by the way, you can do if you go into the console, there's like a auto shutdown. Set your machine to turn off automatically after you finish using it. So if you like leave the machine and leave it idling, I think it'll turn off after this much time by itself. So if you're forgetful, I've totally left this on overnight myself, like many times. I mean, it's not catastrophic. It's only 60 cents per hour, but that adds up. So like if you go on vacation, for example. So best to deactivate, to have that running. So I'm going to deactivate this. So are we done with it? So this is already gone. Anything we want from this? Do you want to save the shoes? I'll just save this right here, yeah. Save the shoe. Okay, now I'm going to deactivate. Any others? It's Friday night after all, so I think people are getting restless. Yeah. Yes, please, yeah.
Hi everyone. Hey. So, time to say goodbye. I thought I'd just say a couple of things. If you don't know me, I'm Hector. And I teach here in SCM. I think many of you know, those of you who don't. Hello. Just wanted to say goodbye to everybody and say a few thank yous before we finish. First and foremost, I think we should all say thank you to Gene Kogan. Really thank you. It's been great. It's been very intensive for 5 full days. I think we've all enjoyed it a lot. So I also wanted to thank all of you for being here. And I especially want to thank you because our university at first thought nobody's going to come. Nobody would be here for this kind of event. So it's great, and thank you all for your patience, and it's amazing. there are still so many people after so many days. I also wanted to mention that I'm one of the co-organizers, but I'm just the laladoy for this kind of thing. I'm just a cheerleader. That this whole event was really the brainchild. It was the idea of Tomás Laurenzo here from SCM. He's a professor here, and just wanted to say thank you to Tomás and to acknowledge him for organizing all of this. Although I think they're not here, but the people from the U.S. consulate have been really great, and we've spent a whole week making fun of Trump. But the people in the consulate have really been great, and they've supported this whole event. Without them, this could not have been possible. So thank you to the U.S. consulate. We also wanted to mention, for those of you who are interested, we will continue to have events on machine learning and on computer-based art. We will have a course in SCM, in the School of Creative Media, on machine learning and art, and Tomás just received a grant with a lot of money to develop this course, and this will become part of the curriculum in SCM from now on. If you have children, encourage them to apply to SCM. And it's really going to be part of our curriculum from now on. I don't know whether, Tom, you want to say anything?
No, just to thank everybody for being here. To mention that as we said on the first day, we are organizing at SCM a conference for this January, which is going to have a core track on machine learning and art that Hector and I are organizing. We also will be presenting our work there. We have our own artistic practice that involves machine learning quite often. What else?
And if you have any work that you produce as a result of this workshop, or if you're working on machine learning and you're doing creative work, you're very welcome to send it to us. Look at the website for the conference. It's called Art Machines. Should be easy to find.
I think it's there's a tally to society here with the link. It's ISCMA, I think. And also we've been discussing with the dean of the school to have a more advanced course on machine learning and art for those who want to dig deeper into the area. We don't know when it's gonna be or if it's actually gonna happen, but most likely after the conference, so something like February or something like that. And again, thanks everybody. Have a nice weekend.
Thank you.